Hello everyone. In this video, I'm going to review Chapter 6, Section 6.1. In this review is in the form of a multiple choice. So the first question says, find the critical value z sub z that corresponds to a 98% confidence interval. So that means that the c is equal to 98%. And if you would like to turn that into a decimal, that is 0.98. So if this was not provided in the table, so what I mean by that is you will be provided with a z-score table. When you look at the z-score table in this particular one, the level of confidence, there's some of them that are given to you that you do not have to find. So in this case, we have 0.98. So the critical value, the z-score, is going to be 2.33. So we can get this answer to be A because it's given by the z-score at the z-score table at the bottom. Let me erase that. So, but I will also like to go over how to find it if it's not given to you, the z-score table. And this is the one that is at the bottom, so we did not really have to find it. But let's say that they give you a z-score. The z-score was not in the table. So the way you will find it, it will be that you draw the normal curve, and the c represents the middle of the table here, the middle of the normal curve. So the 98% is 0.98, so that represents the area under the curve. I added 2 zeros to make it be 4 decimal places, because when we actually look for this, will be in the body of the table, the z-score table. So we are interested in finding the negative z-score and the positive z-score that represents the area under the curve. But since everything adds up to 100, that means that in order for me to find the tails that are going to have the same area, all I have to do is subtract the 0.98 from 1, and that will give you 0.02. But that is the sum of the two areas. So if I just want to find the area for 1, I divide that by 2, and that tells me that this area is 0.0100, and this area is also 0.0100. So what you're going to do is choose to find the z-score, the negative z-score, because that will give you the area to the left. And the table is designed to give you areas to the left. So we're going to look inside the body of the table, and if we don't find the exact value for this area, it will be an approximation. So we're going, since we're finding the area to the left, so it will be a negative z-score. So you look inside the body of the table, and we're looking for the closest one or the exact value. If you look in here, this one is 0.0099, then we have 0.0102. So the closest one is 0.0099. That is the closest to the 0.0100. So the closest to that one was 0.0099. So the reason why the answer is 2.3, and it's a plus or a minus, is because this area is represented by the z-score of negative 2.3 and then plus 0.03. So that gives you the z-score of 2.33. And since there are two z-scores that we're looking for, because one is negative and one is positive, that's why you see that there is a plus or minus in front of that z-score, because they represent the same areas under the curve. So that is how you will find it if it was not provided to you. So we proceed with question number 2. Determine the sampling error. So I wanted to highlight the keywords, sampling error. Determine the sampling error. So when you look at the formula sheet, there is a formula that will say sampling error. So, and that formula, in the formula sheet that you will be allowed to use, this is a formula sheet, and we're emphasizing final exam formulas because you will be provided with the same one. So the sampling error is right here. The sampling error formula is the sample mean minus the population mean. So in other words, x bar minus mu. So you are provided with those two values. It says determine the sampling error if the grade point average for 10 randomly selected students from a class of 125 students has a mean of 2.3. So x bar, or the sample mean, is 2.3. Assume the grade point average of the 125 student has a mean, a mu of 2.7. You always subtract the population mean from the sample mean, and in this case this is going to be negative 0.4, and this is answer B for this question. So it's a very simple question. So as long as you identify the keywords, that will help you see what is the formula to use. We have another exercise with the keyword sampling error. So you're looking for the sample mean and you're looking for the population mean. Those are the two set of data that you need. Again, the formula for the sampling error will be provided in the formula sheet. So this is x bar minus mu. So in this case is 2.3 minus 2.8, and this also a negative 0.5. That's your final answer. And in this exercise is part C. Very simple question, so I hope you understand the process. And the next one, find the margin of error for the given values of confidence level, population standard deviation, and sample mean. So they give them to you like that. So this is just to emphasize calculation. So again, the key word here is margin of error. So the margin of error, it will be another formula that will be provided to you. So the margin of error is found by the z-score multiplied by the standard deviation divided by the square root of the sample. And the keyword is, this is based on section 6.1, so it's based on the population being known. So here the population is given, the population standard deviation is given, so you will be using the margin of error E equals the z-score based on the confidence level, multiply by the standard deviation, population standard deviation, divided by the square root of the sample size. So in this exercise, we replace the values, and again, we look for the z-score of the confidence level of being 0.90. So you refer back to the z-score formula. You look at the bottom of the table, and in here it says indicates that the 0.90 or 90%, the z-score is 1.645. Since it is given to us, we don't have to worry about finding it. So the z-score 1.645. So that will be the value that you will multiply by the population standard deviation, and you will divide it by the given sample size, that is 75. So you can choose to enter this part in parentheses. So I will demonstrate with a simple calculator. So this is a TI-30. So I will enter the 1.645 multiply, and I like to enter that fraction in parentheses, 10.2 divided by second square root of 75. So in this calculator, it opens a parentheses for the value under the square root. So notice that I closed that parentheses, but I also have to close the parentheses that is in front of the 10.2. And then you press enter. So here I'm getting a margin of error that is 1.937. So 1.937. So it says to round it to, if you look at the answers, they all have 2 decimal places. So this will be 1.94 because the 3 is followed by a 7. So you increase that last digit by 1. Okay, so far all of these questions are from section 6.1. So now we're going to go to the next questions. There are 4 additional questions that are also part of the review for section 6.1. So in this question number 5, it indicates that a random sample of 150 students, so that will be your sample size is 150 students, has a grade point average with a mean of 2.86. So the GPA, the mean GPA is 2.86, and that refers to the sample mean because it is after the sample size. So it says assume that the population standard deviation, is 0.78. Construct the confidence interval. So they want you to find the confidence interval for the population mean. So in other words, they have this sample of 150 and they want to see how close is this to the actual population mean since you're working from the sample. So the confidence level is 0.98. So as soon as I see 0.98, I know that I'm going to have to find the z-score of 0.98. So you go to the table, again the z-score table, and based on the confidence level of 0.98, we're going to be using 2.33. So this is going to be 2.33. And then again, the confidence interval, in order to find the confidence interval, will be expressed in this form. So what that means is that we will need the margin of error, and we're given the sample mean, that is 2.86. So we can go ahead and enter those values there. And what we're going to do is add it to the right side and subtract it from the left side. So the intermediate step is to find the margin of error, because there will always be an error when you're working with a sample. So you want to see how far I am from the true sample population mean. So the margin of error, remember that the formula is the z sub c multiplied by the population standard deviation divided by the square root of n. So in this case, it will be 2.33 multiplied by, so the population standard deviation is given as 0.78 and the sample size is 150. So again, we're going to enter that in the calculator. I am using a TI-30, but it's the same input if you have the graphing calculator. So 2.33 multiplied by, open parentheses, 0.78 divided by second, square root of 150. And I close the outside parentheses. So this is going to give you, we rounded to 2 decimal places. It tends to be the decimal places that are asked for in all of these exercises. So if it is 0.148, it rounds to 0.15. So this is going to be the value that I am adding and subtracting to find my confidence interval. So I'm going to take 2.86 and subtract the confidence in the margin of error. So this will be 2.71. Then I'm going to take the other sample mean and I add 1.5. I apologize, I don't add 1.5, it's 0.15. 2.86 plus 0.15, that will be 3.01. So this tends to be expressed. So the interval, the confidence interval, it is expressed in parentheses. This is called the interval notation for the confidence interval. This is going to be just in parentheses, a different notation. So it's usually expressed in parentheses. If you're working on your homework, make sure that you don't leave a space. It should be 2.71, comma, 3.01. You cannot enter a space because it will be marked incorrect, just to give you the heads up. That's how my stat lab is programmed. So question number 6. In a random sample of 60 computers, so the sample size is 60, the mean repair cost. So the sample mean, it is $150. Assume the population standard deviation. The population standard deviation is $36. Construct a 90% confidence interval. So that is 0.90 for the population mean. So again, we know that we're going to have to find the z-score of 0.90. So we might as well get ready and find it. So you go to the z-score table, and z of 90% or 0.90 is 1.645. So since it is given to us, I don't have to find it. So then after that, you will find the margin of error using the formula z sub c multiplied by the population standard deviation divided by the square root of the sample size. So 1.645 multiplied by population standard deviation of 36, the square root of 60. And again, we round this to usually 2 decimal places. But if you notice here, they all have whole numbers in your confidence interval. So I'm going to round it to a whole number. So I am not that off and I don't have to round the answer at the end. So again, in order to get to the confidence interval, I know that the population mean will be estimated to be here, using the left and the right side of your confidence interval. So the sample mean was $150. Then I will subtract the margin of error. So this one will be $150 plus the margin of error. So I'm going to demonstrate how to find that with a calculator. So this one is 1.645 in parentheses 36 divided by second square root of 60. Close the square root, close the terms in the parentheses in the denominator, and then we press enter, and that we're getting 765 basically. So I'm going to call that 8. So 7.64 is approximately 8. And again, I'm going by no decimal places because none of the answers contain decimal places. So it's going to be 150 minus 8 and 150 plus 8. So that will make it easier to find this value, 142 and 158, and that will be answer D. That matches answer D. So now we just have 2 more questions. Oh, and again, this is expressed in parentheses, 142, comma, 158, but it's coming from the interval notation. So now number 7. In these questions, we're asking you to find the sample size. So the next one, how large is sample? So they're both about sample size. So the standard IQ test has a mean of 97. That's a mean of 97 and a standard deviation of 17. So since it's going to be asking me for the sample size, the formula for the sample size is given to you. So the formula is the z-score multiplied by the population standard deviation divided by the margin of error, and then you square that. So the IQ test has a mean, so my x bar is 97 and a standard deviation of 17. We want to be certain 95%. So that is equal to 0.95. So that means that my z-score of 0.95 is what I will be using. So again, we'll find that score. Hopefully it is in the z-score table. So 0.95 is at the bottom here, and that is 1.96. So I'm gathering from the bottom of the table. If it is there, we just use it. And then we have to look at another keyword here. It says within 5 IQ points. So within 5, that means that the margin of error is 5. Remember that we add and subtract the margin of error plus or minus the sample mean. So that's why the keyword is within. That implies margin of error. So this is E, margin of error is given. So we have all the numbers that we need in order to find the sample size. So the z-score 1.96 multiplied by the population standard deviation 17 divided by 5 and then raise it to the second power. So we'll enter those values in the calculator, open parentheses, 1.96 multiplied by 17 divided by 5, and then you square. So I don't enter any additional parentheses in here. So we are getting 44.41. But if you look at the answers, when you're looking for the sample size, you always round up. So naturally, if you did not, we're not told you have to round up, you will say that the answer is 44. But it doesn't matter what decimal points you have after the whole number, you always round up. So this one will be 45. So we sometimes have a problem with this one. In this case, we only have 45, and you don't have to decide between 44 and 45. But in the next exercise, it will make a difference. So just keep in mind, you always round up, whether it rounds up or not. Always rounds up. Always, always. So remember that. So in the last question over section 6.1, we have a nurse at a local hospital that is interested in estimating the birth weight of infants. So how large sample must she select if she desires to be 99%, so her confidence wants to be 0.99, that the true mean is within, so within means that my E is 4, and the standard deviation is 9 ounces. So we don't have the Z, so the Z of 0.99 hopefully is given to us at the bottom of that table, so we don't have to add another process. So 0.99 is given to us, 2.575. So we recall the formula that will be given to you at no additional cost. So make sure you count that as part of your blessings for today and this semester. So, well, first we'll make it equal and then we estimate it. So this is equal to, so the N is equal to your Z value, 2.575 multiplied by the population standard deviation divided by E, that is 4, and then you square. So again, we always will round up. So I'll demonstrate how to enter that in the calculator. Open parentheses, 2.575 multiplied by 9 divided by 4, square. I pressed X square. So that is, we are getting 33.57. But since you always round up, this is going to be 34. And that's it for the questions over section 6.1. I hope this helped you understand these concepts better and prepare you for a wonderful grade on this exam. Thank you so much.